Hey everybody, today we're going to talk about factoring quadratic expressions using the area model when a is 1. You may be familiar with this model from Algebra 1 or from prior experience, but today we'll do a nice refresher on that. So let's talk about what factoring means. Factoring means we're going to break something down into smaller parts. Now in mathematics, that means division. So when I say the word factoring, that means we are going to be dividing. Here are some examples of quadratic expressions. Now, what is our goal for today? Our goal for today is to break these expressions down into their smaller pieces, and we're going to do that using the area model. And again, that means factoring. So let's take a look at our first example. Factor the following quadratic expression, x squared minus 7x plus 10. Okay, so here's how we work this out. We want to draw a couple of squares, a couple of boxes. And the reason for this is really because we need the area model to factor it. It'll help us kind of streamline our thoughts a little bit. Here's how we do it. The x squared term, that term, the squared term, will always go in our first box. Now, the constant term, or the only value up here that does not have a variable attached to it, which is positive 10, will always go in the bottom right-hand corner box. Now, obviously we have two boxes that are not filled yet. Well, we're going to use the middle term, negative 7, to help us do that. The reality of this is we're going to have to do a little bit of arithmetic off to the side. So we're going to take that constant term, and that was 10. Now, what we're going to do with that 10 is we're going to try to figure out two numbers that we can multiply to get to 10, but we could also use those two numbers to add or subtract to negative 7. So let's do that. I know that when I try to get a 10, I know it's either 1 times 10 or 2 times 5. I can't really go anywhere else because we're not talking about fractions or decimals. That would make this process way too hard. So which one of these two pairs could I use to manipulate with addition or subtraction to add to negative 7? So if you said 2 and 5, you're right. So how can I make a 2 and a 5 add to negative 7? Now again, if I'm going to manipulate it with adding or subtracting, that means that I can use any combination of plus and minus signs. Well, the only way to make a negative 7 is if I make both the 2 and the 5 negative. So I'm looking for a negative 2 and a negative 5. Now, we're going to put those into these two boxes. Couple things to remember. Number one, it doesn't matter where the numbers go in order. It could be negative 2 and negative 5. It could be negative 5 and negative 2. That doesn't matter at all. The order doesn't matter because it'll always work out in our favor either way. Now, I'm just going to put the negative 2 here and the negative 5 here. One thing to remember, or the second thing to remember really, is to put x's behind those, or whatever variable we were using in the process. The reason for that is because it's not really a negative 2 and a negative 5 anymore, because it came from the negative 7. Okay. Once we filled out our basis of the squares, or the area part of the squares, now we're going to have to kind of go backtracking a little bit in order to find the factors, because we're not there yet. So here's how we do this. Let's take the x squared and the negative 2x. What is the greatest common factor, or what is the greatest common thing that I can take out of both those numbers? Well, I can't take a 1 out because I could take a 1 out of everything if I divide. But what do they both have in common? They both have an x in common, which means I'm going to take an x out and I'm going to put an x right there. All right. Well, let's continue with this process. If I have a negative 5x and a 10, and I'm trying to get a number up here, or a thing up here, what do both these things have in common? What can I divide out evenly? Now, it's not so easy with this x because this doesn't have an x. The 10 is just a constant term. But if I'm trying to divide out something evenly, they both have a 5 that I can divide out evenly. All right? Now, key rule of thumb, if this term or this term has a negative has to come out with it. Okay? So this is going to be a negative 5 up here. Now we're going to go towards the other side here. X squared and negative 5x. Well, what do they both have in common? They both have an x in common. So I'm going to take that x out and write it to the side. And then we'll finish this off with the last two sets here on this bottom row. What does a negative 2x and a positive 10 have in common? Well, again, this term is a negative, so I have to lead out with the negative. So I'm going to divide out a negative first, and they both can be divisible by 2. So minus 2 comes out here. All right, now we are done. What do you mean we're done? It just means that we're done. We're done. Okay, so we have an x minus 5. And we have an x minus 2. So I'm going to rewrite it to the side here. So our factors are x minus 5 and x minus 2. And we are done. Those are the factors of the quadratic expression x squared minus 7x plus 10 using the area model. Moving on. Okay, Let's go ahead and try our second example. B squared plus 8b plus 7. And again, we always want to have our squares there. If they're not given to you on the paper, you're definitely going to want to go ahead and draw them for yourself. All right, well, same process exactly. The only difference really that we see here is we see a couple of positive signs as opposed to a negative in the first problem. And we also see the letter B instead of X. Don't worry, it doesn't matter. We're still going to enter our values into the squares the same exact way we would normally. So let's go ahead and start that process off. We always will start with the squared term. B squared is going to go in this upper left-hand box. The constant term, positive 7, is going to go in our bottom right-hand box. You can put the positive if you want to, or you can just put the 7. It doesn't matter either way. Now again, we have our two empty boxes, which is we're going to have to find out what combination of multiplying to get 7 to get to 8 with addition or subtraction. Well, 7's easy, because the only way to get a 7 is 1 times 7. And the only way to get an 8 with addition of these numbers is 1 plus 7. So, because I need a positive 8, they are both going to have to be positive signs. So we found our combination of addition or subtraction. So let's plug them into the values that we know here. And again, it doesn't matter. We're just going to put a 1b into this one, and we're going to go ahead and put a 7b. So now that we have our combination of the breakdown, let's just go ahead and get greatest common factors and work it out. What is the greatest common factor of b squared and 1b? Well, if I divided something out evenly, they both have a b. So I'm going to plug this b or take this b out and put it right on top. 7b and 7, what do they both have in common that I can divide out or factor out? Again, this is greatest common factor all the way, right? So 7 is the number that we're looking for here. So that's going to be a plus 7. And as you can see, we've got something similar to our first problem. This is actually going to be our first pair of factors. Let's go to the side now. B squared and 7b. Well, the greatest common factor there is just b. You're seeing the pattern, hopefully. 1b and 7, the only thing I can take out of both those things is a 1, meaning divide or factor. And again, we're going to have our answers. I know those parentheses are a little weird, sorry. Our factors, or our final answer, are b plus 7 and b plus 1. And that's a plus because I had to take the plus out. All right. Now, let's go ahead and try one more problem. Okay, for our final problem, I'd like you to try it, so you can go ahead and pause the video, and then I'll go through the process with you together. So we're going to factor the following quadratic expression, n squared minus n minus 56. Just one key point or one hint, the middle value is a negative 1. So if you don't see a number there, it's going to be kind of like the same thing about their coefficient in the front. It's going to be a value of 1. All right, so go ahead and, okay, so hopefully you had a minute to pause yourself and work this process out. Let's do it together. Again, the squared term is always going to go in our first box in our upper left-hand corner. So this is going to be n squared. The negative 56 is going to be in the bottom. And again, that's going to be a negative, so be careful of the signs. Now, I'm looking for numbers that I can multiply to get to negative 56. So I'm going to do that to the side. That I could use to add or subtract to get a negative 1. Okay, now this is going to be a little bit weird because there are multiple factor pairs of negative 56. So we're going to go through this process, right? So I know I can do 1 times 56. And again, there's signs here, but let's try to get the numbers first. 2 and 28. 3 doesn't fit in evenly. 4 and 14. 5 doesn't work. 6 doesn't work. And then we have a 7 and an 8. So hopefully you chose the right factor pair. What we're going to need here is a 7 and an 8. Now this is going to be a little bit trickier because I have to manipulate the signs to make it work. Remember that I have a negative 56 and a negative 1. Now, what is it that I'm going to need here? Well, because I'm trying to add or subtract to negative 1, meaning the result needs to be a negative, the bigger number has to be a negative as well. So I'm looking for a negative 8 and a positive 7, because negative 8 plus 7 is negative 1, and we can always double check and say, well, negative 8 times 7 is negative 56. So we're good there. So again, I'm going to plug in my numbers, and it doesn't matter how. As long as we put the variable behind it, we are good to go. Okay, now let's go ahead and figure out the greatest common factors of these things. N squared and negative 8n, well, they both have one n in common, so I'm going to plug an n up top. 7n and negative 56. The only thing I can factor out of both these things is a 7, right? So 7 is going to go on top here. I want to make sure you can be able to see that. And that's going to be a positive because that 7 did not lead with a negative. Here to the sides, n squared and 7n. What's the greatest common factor of both of these? And that's going to be an n. and then a negative 8n and a negative 56. Now, because again, this term leads with a negative, I'm able to factor out or divide out a negative sign. And a negative 8 is what I'm looking for. So I have my factors and our final answer. Ooh, factors. I don't know what that was. Sorry. n plus 7 and n minus 8. And we're done. All right? Very cool. Okay, so to wrap up the video, a couple of things to remember about factoring quadratic expressions when a is 1 using this area model. Number 1, factoring is division. That's one of the biggest parts of this entire video. Please remember that when we say factoring, we are trying to divide or take something out that both things share. Number 2, always draw squares to help. The area model is a little bit misleading because it's not exactly the same length as that expression would be, but squares will work no matter what. It still gives you the exact same thing. And number 3, the coefficient of the squared term is always 1, particularly when we talk about when a is 1 in this quadratic. So you're always going to have that 1 in the front. In subsequent videos, you're going to see other numbers in there, but the process remains the same. See you later.